Okay guys, today we're going to learn about relationships between structures and physical properties. Yeah. But before we can learn about the physical properties and how they relate to structures, we have to first remember what intermolecular forces are, right? So can you guys list some intermolecular forces for me?
Hydrogen bonds.
The hydrogen bond. Okay, the second one. Second one, guys. Okay. We have ion, dipole. Third one is
Dipole.
dipole, of course. And the fourth one is weak
van der Waals.
But can we apply this one in organic chemistry? Ion dipoles, this one. We can't, right? Because ion dipoles happen when we dissolve ionic bonded compounds like NaCl, like CaCl2 in water, and then the water molecules, the positive parts of water, become attracted to what the non-metal, and then the negative parts of the water become attracted to the metal. Yeah. So here we're not dissolving anything, so we're not going to talk about this one. We're just going to talk about hydrogen bonds, dipole, and weak van der Waals. Right? Okay. So let's see something. When it comes to hydrogen bonds, which elements form hydrogen bonds?
Hydrogen.
Okay, hydrogen, and what?
Oxygen.
Oxygen, ne? What else? Fluorine, guys, fluorine. Okay, I'm guessing you don't know the last one either. The last one is nitrogen. And this is how you can remember them. Yeah, this is how you can remember how these three form hydrogen bonds with hydrogen. Look at the placement of oxygen in your periodic table, right? What comes before oxygen in your periodic table? We have nitrogen. What comes after oxygen in your periodic table? We have fluorine, right? So always look at where oxygen is, the one next to and the one after oxygen. Those are the ones that will form hydrogen bonds. So wherever you see HO, HF, or HN, we have hydrogen bonds. Also, these ones are the strongest. Followed by, okay, so if we come to dipoles will happen between polar molecules, right? So the intermolecular forces between polar molecules. Basically, these ones are also dipole, but they are a very strong type of dipole. So the dipoles will happen between polar molecules that don't have hydrogen bonds. So these ones are strong, since they are stronger than the last one. Strong, and they happen between polar molecules. Like water, for example. Water consists of polar molecules. So let's go to weak van der Waals. These ones, as the name suggests, are
Weak.
Yes. These ones are weak, and they will happen between non-polar molecules. Right? So now we have the basic background, right, of what intermolecular forces are. So let's go to our physical properties. Physical property number 1 is boiling point, which we all know. So we all know what boiling point is. Boiling point is the point at which a liquid will turn into gas. So the temperature at which a liquid will turn into a gas, we call that the boiling point. Ne? So if we have boiling point as our first physical property, obviously we will also have
Melting point.
exactly melting point. So we also have melting point. And what is melting point?
Solid to liquid.
Right. So it's the point at which solids turn into liquid. The temperature at which solid will turn into a liquid. So for example, when it comes to ice, so when ice melts into water, it melts at 0 degrees. That 0 degrees is the melting point. And then the water will boil, and then when it boils, it turns into a gas, which is water vapor, and it boils at what degree?
100 degrees.
100 degrees, which you all know. So that the boiling point will be 100 degrees for water, and the melting point will be 0. Okay, so the third one that we have is viscosity, which I will explain just now. And then the fourth one is vapor pressure. So sorry. Vapor pressure. These are the ones that we will be talking about today. We have vapor pressure, and with vapor pressure, it's the pressure. It's the amount of pressure that gases exert on a container or on a liquid. So here we have, for example, this is doom. We all know doom. This is doom. So the vapor pressure of doom is very high because it is compressed to the point that it has no point but to form a liquid. So the vapor pressure is very high. It is actively acting on the can. So as soon as you create even the smallest opening, since there is so much pressure, the gas will quickly escape. So this has a very high vapor pressure. And can you read this part for me? What does this say next to safety information?
Highly flammable.
Right, so this is extremely flammable. So that brings me to the next point, which is flammability. So now if you look at this doom, when you feel it, I know we all know the temperature of doom. It's cold, It's cold when you feel it, And that tells you that it is gas at room temperature. If it is gas at room temperature, that means that it probably has a very, very low boiling point at which it turns into gas. So it has a low boiling point, which means that if a substance like doom has low vapor pressure, it will have a very high boiling point, and we will also have very high flammability. Remember when we were reading here, it says it's highly flammable. That is because substances with high vapor pressure tend to have high flammability, low boiling point, and low melting point. And then we will come to viscosity just now. And then last but not least, we have smell. For today, these are the ones that we will be talking about. These are the properties. Not to say that these are the only properties. We also have density, and we also have solubility. So yes, these are the ones that we will be talking about. Let's come to the smell. So when it comes to the smell in organic molecules, when it comes to actual functional groups within the same functional groups, different length will cause a different smell, but the general is that the ones with hydrogen bonds, in fact, the molecules with oxygen in them will tend to have a pungent or sharp smell, right? And then the ones that only have either The ones that are haloalkanes or just alkanes will be odorless. They will be generally odorless. Yeah, so that is the general rule when it comes to smell. Now let's come back to viscosity. In order for you guys to understand what viscosity is, we are going to have to take an actual closer look at how it works. Okay, so here is an inclined plane, right? And we're going to test the viscosity of water, oil, and honey, right? So the one that takes the lowest time to get to the bottom, like to travel down the inclined plane, has the highest viscosity. Viscosity is basically resistance to flow. So the one that resists flow more is the one that will basically have the highest viscosity. So first we will start with our water, which we all know, yeah, it's very easily flows. Okay, so we will start and we will count how long it takes because we don't have a stopwatch. So 3, 2, 1, go. 1, 2, 3. Okay, that was very quick. Next we will try the oil. Let's see how long it takes the oil to get to the bottom. 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, yeah, it's taking too long. It's taking too long, but it reached this point at 18. So we'll try the same thing with honey. Yeah? So let's see. Honey. 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's not even flowing. Oh my god. It's not even flowing. So if we maybe lift this up, okay, the oil is flowing a bit faster, and now the honey is also starting to flow. But as we can see, the honey is the slowest to flow, which means that the viscosity of the honey is the highest. Yes. So now we know what viscosity is. Viscosity is a substance's resistance to flow. All right. Okay. So now let's try and see how organic molecules would have different properties. Let's start with alkanes, right? Alkanes are easier. So let's just start with alkanes. Let's start with propane. So if we have a molecule of propane, so let's see. So we have CCC, right? Along with its hydrogens, right? And then we have another CCC. Okay, so now these two molecules will be attracted to each other, but since they are both nonpolar, here's how they're nonpolar. These hydrogens will cancel out the polarity. These ones will also cancel out. These ones will also cancel out. These ones will also cancel out, right? Otherwise, the hydrogen, there's a difference between the electronegativity of the hydrogen and the carbon, but the hydrogens, since they are symmetrical, will cancel out that electronegativity. So it becomes nonpolar. Okay? So these ones are nonpolar, which means they are intermolecular forces, but these intermolecular forces are weak van der Waals, right? So these ones have weak van der Waals, which means that they have the weakest intermolecular forces. If they have the weakest intermolecular forces, then obviously they're going to have they're going to have a high flammability. So high flammability, they're also going to have high vapor pressure. And then they are going to have the lowest viscosity. And they will also have Okay, viscosity can also be interchanged with density because they are directly proportional. So the higher the viscosity, the higher the density. So low viscosity, they will also have a low boiling point and a low melting point. Obviously, if your boiling point is low, then your melting point will also be low. Okay, so now